everyone. Today we are going to start our new session. Let me introduce myself. I am Bodhi.S. Dharman.
I'm Aleena Elsa Raj.
I am Merlin Abraham.
First of all, let's see a interesting video. Aleena,
Yes, I'm sharing the screen.
okay. From the video, it is clear that today we are going to discuss about displacement reaction. So, what is a displacement reaction? A displacement reaction is a type of reaction where a more reactive element displaces a less reactive element. There are two types of displacement reaction. They are single displacement reaction and double displacement reaction. First, we are going to discuss about single displacement reaction. Single displacement reaction are reactions where one reactant replaces part of other. For example, AB plus C gives AC plus B. Here, C displaces B and C acquires the position of B. Then we get the product AC plus C. Then next we are going to discuss about double displacement reaction. Double displacement reaction is reaction takes place when two elements switch its cations. Then we are discussing about the reactivity theory. The reactivity of metals is described as how easily an atom loses an electron. The reactivity series is the arrangement of reactivity series of metal in the decreasing order of their reactivity. That is, more reactive metals are arranged in the top and less reactive metals are arranged in the bottom of the series. So, potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum are the metals. Here, potassium, sodium, calcium, magnesium, aluminum have the most reactive metals and Copper, silver, gold, platinum are the less reactive metals. For instance, potassium is extremely reactive because it has only one valence electron, so it is very easy to lose it forming a positive ion. Whereas on the other hand, copper is a weakly reactive metal because it has more valence electrons, so it is harder for it to become a positive ion. So once again, what are displacement reactions? A displacement reaction is a type of reaction where a part of one reactant is replaced by another reactant. There are two types. First one is single displacement reaction and double displacement reaction. Single displacement reactions are reactions where one reactant replaces part of the other. Double displacement reactions are reactions where part of one reactant is replaced by part of another reactant. Now I am handovering this session to Aleena.
Okay, now let us discuss the single displacement reaction in detail. First of all, we can discuss the definition of single displacement reaction. A single displacement reaction, which is also called as single replacement reaction, is a kind of oxidation reduction chemical reaction when an ion or element moves out of a compound, that is, one element is replaced by the other in a compound. So we can discuss some examples in this single displacement reaction. The first example is when chlorine is added in its gaseous form or as a gas dissolved in water to the solution of sodium bromide, the chlorine acquires the place of bromine. Since chlorine is more reactive than bromine, it displaces bromine from sodium bromide and the solution turned blue. The brown color is the bromine that is displaced. So here is the chemical equation for the above reaction. Cl2, which is in aqueous solution, plus 2NaBr, which is also aqueous solution, gives 2NaCl aqueous solution plus bromine. So you can see that if you notice this equation, you can see that chlorine and bromine have swapped their original positions. So another example for the single displacement reaction is if we are dissolving zero point 0.5 gram of silver nitrate in 10 ml of water in a test tube and a copper wire is then dipped in it and kept undisturbed for some time. The shining silver crystals are visible on the copper wire and the solution becomes bluish as some amount of copper is developed. So in the above reaction, the copper metal displaces silver from silver nitrate solution. And the chemical equation for the above reaction is Cu plus 2AgNO3 gives 2Ag plus CuNO3 twice. So this is all about single displacement reaction. Now we can move to double displacement reaction.
Yes. We discussed about what is displacement reaction, and there are two types of displacement reaction. First one is single displacement and next is double displacement reaction. To make this double displacement reaction more clear, we can see a video. So this is an experiment. It requires two test tube and barium chloride solution and sodium sulfate solution. So take a 3 milliliter of, Aleena, can you see this? Yes. Yes, this is an experiment and we need two test tube and take sodium sulfate solution and barium chloride solution. Take 3 milliliter of sodium sulfate solution to a test tube and barium chloride solution to another test tube. And now mix these two solutions. What we get? Yes, a white precipitate is formed and this confirms the presence of sulfate in that solution. Now keep this test tube undisturbed for 10 minutes. After 10 minutes, we can see that a white precipitate is settled down to the bottom of that test tube. Now we add a dilute hydrochloric acid to that solution and we can observe that a white precipitate is insoluble in dilute hydrochloric acid. Yes, we can see here. Yes, we get an equation that is sodium sulfate react with barium chloride and to form barium sulfate and sodium chloride. And this is an example for double displacement reaction. Here actually what happens, the sulfate ions are displaced by chloride ions and the chloride ions are displaced by sulfate ions. So that is double displacement reaction. And now we can see the PPT. Yes, double displacement reaction is a reaction that occur when a part of two ionic compounds are exchanged and make two new compounds. And this reaction takes place mostly in aqueous solutions wherein the ions precipitate and exchange of ions takes place. And the example for this double displacement reaction is sodium sulfate react with barium chloride and to form barium sulfate plus sodium chloride. So that's about double displacement reaction. Hope you understood this reaction. And now I invite Bodhi for the next session.
So we have understood what is a single displacement reaction and double displacement reaction. Now we are going to discuss about the application. First is the position of the metals can be predicted by carrying out reactions using the reactivity series, that is whether a metal belongs to most reactive metals, moderate reactive metals or the least reactive metals. You can make predictions about the reactions of unfamiliar metals if you know their position in the reactivity series. The reactivity series can be used for the applications of electrolysis for the extraction of certain metals from its compounds, which doesn't exist as single element. Extraction of sodium from its compound, it is difficult to find some reactive metals as single element. It can be only found as compounds, so to separate these metals from its own electrolysis should be carried out using their reactivity order. For instance, to get sodium electrolysis should be carried in molten state for to get discharge. The next application is prevention of rusting, that is to choose which element can be used to prevent rusting reactivity series is required. First one is electroplating, then galvanization and sacrificial protection. Electroplating, to coat iron with a metal which has a high reactivity, so it corrodes with air before the iron gets rusted. Then galvanization. Galvanization is similar to electroplating, except for the fact that we use zinc and sacrificial protection is process on which in more reactivity metal sacrifices it like to prevent. We use zinc to in the galvanization reaction. So these are the applications of displacement reaction. Hope all of you understood our topic. Have a nice day.
Thank you.
Thank you.